Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Happy Tuesday to you, mi amigos. And I have to tell you, I love the solar system. I love studying the planets and just what they're like. And today we're going to Mars. And there are a few of you, actually, after we go to Mars, then I'm going to leave you on Mars. The rest of us are going to come back, but I'm leaving you up there. Just kidding. It was a little joke. So, not really going to happen. But we get to go to Mars. And I love studying Mars. By the way, Mars is right now a prominent object in the eastern sky, 8 p.m. in the east. You still have Saturn and Jupiter closing on each other, closer, ever closer and closer, coming as close as they've ever been in 400 years, count them, on December 21st. The Great Conjunction. Conjunction means just to join. You've got con, that means with, junction, join, to join with each other. That's the idea. They're not even close to each other, they're like that. One's going to be, one's away in front of the other because of their great distance in their orbit and their closeness to the sun. I mean, they're tens of millions of miles apart in their orbits around the sun, but they look like that they're close. So anyway, keep looking at Jupiter and Saturn. Venus is still up there early morning in the east, still there, brightest planet because of its high albedo reflectivity, because of its carbon dioxide atmosphere. So anyway, so we better get going, huh? Okay, hey, just a reminder, good grief, yak. Just a reminder about the lesson summaries. I'm building the tests off the lesson summaries predominantly. That, your journal, and also your verse sheet. So what verse this week? It's Psalm 19:1 again. Say it with me. The heavens declare the glory of God. The sky above, I think it proclaims his handiwork. Okay, so I'm close. So Psalm 19:1 this Friday, on Friday's test. And I'll be telling you more later, but it's going to be a focus on the planets. So this Friday. Okay, here we go. Hey, on your white sheet, if you would number to 10 on your white sheet, quick, on your white sheet, number to 10. And just a little review. It's not a pop quiz. Tomorrow could be a pop quiz. Just saying. Okay. In 1 through 4, 4 characteristics of the inner planets. 1 through 4. Quick. Characteristics of the inner planets. Numbers 5 through 8, characteristics of the outer planets, 4 of them. Hey, this could give you a score if you get a perfect on this. Yeah, if you get a perfect, I'd give you a 10 out of 10. You have to get a perfect on this, though. Or a 9 out of 10. That's it. 9 out of 10. Or 10 out of 10. So 5 through 8, characteristics of the outer planets. Think about what they're like, just visually, the outers, what they're made of. The outers have a lot more characteristics that I mentioned. Are some of them just opposite of the inners? Yes, they are. You're welcome. Okay, number 9 now. Number 9. So how are we doing time-wise? Good. Okay, number 9. Number 9, what do we call Space is like this, but what do we call any environment where all the matter has been sucked out? There's no matter. No atoms at all. Not a good place for us to live, by the way. We couldn't survive. So number 9. And Mars is almost this. Almost. So what do you call an area, number 9, where there's no matter, no atoms? Number 10. What is the term we use for weightlessness? So in space, no gravity is felt, so you're weightless and you float, which would be fun. Wouldn't it be fun? Is it on your bucket list? No, I don't think I'll ever have the opportunity to do it, to experience weightlessness. Or the answer, number 10. You know there's a way to do it, but it's quite expensive. In Apollo 11, the astronaut crew in Apollo 11 got to do this. In fact, this is, I don't know if they filmed some of it by doing this. You can actually go up, say, to 35,000 feet in a special airplane that's got padding around it. And if you dive toward the Earth, literally the plane dives toward the Earth for about 30 seconds, you can experience weightlessness. Hands up if you've ever heard of that. Mr. Gilbert's seeing it. You ever heard of that? So the Apollo 11 movie crew got to experience it. So that's number 10. Okay, here are your repeats really quick. 1 to 4, 4 characteristics of the inner planets. 5 to 8, 4 characteristics of the outer planets. And number 9, what do we call it when all of the matter is gone from an environment? No atoms, no matter. Term for it. And then weightless conditions. Number 10, space is like that. Number 9, no matter. Number 10, weightless. All right, here are your answers. You can use that pen or pencil you just wrote with, but you've got to initial down below your promise to me and the Lord, okay? And you're impressing Mr. Gilbert right now with your honesty. Okay, I like giving you this opportunity. How come you're not having us take out a red pen? Because I want to give you an opportunity to just be honest, without having this particular regulation in place. Can you do it? I hope so. So that's what the Lord wants. And your initials mean that you're promising Him and me. More importantly, Him. You're promising Jesus, I'll be honest as I grade this. Okay. Isn't it sad if you had someone who, let's say they got an 8 out of 10 on this, and they change a couple of answers real sneaky like, and then they write 10 out of 10 and hand it in. How do you think their conscience would feel? It would bother them. That's the Lord speaking using the conscience. Psst, you cheated. Psst, you cheated. That's your conscience. Yeah. Make it right. You need to apologize. You need to admit it. Conscience. Yeah. That's the way it works. All right, here are your answers. 1 through 4, the inner planets are small compared to the outers. They're rocky or solid or terrestrial, as they're called. They have few or no moons. Few or no moons. They're slow rotators and they're fast revolvers. They've got to be fast because they're closer to the sun. Okay, that's 1 through 4. The outer planets, 5 through 8. The inner planets are small. The outer planets are huge. The inner planets are made of rocks. They're solid. The outer planets are gaseous, made of gas. The outer planets are fast rotators compared to the inners. And the outer planets are slow revolvers. They don't need to revolve as fast as the inners. The outer planets have lots of moons. The Italian, lots of moons, and the outer planets have rings. All of them have rings. Some of them you can't see very well, but they've got them. Okay, so they got rings. All right, before we go to Mars, I wanted to go over test number 7. Now, This is for some of you RLO students. For some of you RLO students, I still don't have your test number 6. Not this one that you did last Friday, but the week before. I still don't have them posted. I'm looking for them today. If you finished it, post it to me on Teams. And all your assignments. Get those babies in. Oh, there's 10 minutes right there. I'm going to a quick break, really quick, with Mr. Gilbert just to check anything, clarify anything. Okay? He could maybe clarify my freebie policy right now too, where if you don't get an assignment, then automatically, unless you were sick, then automatically you burn up your freebie, because I don't have time to play chase down homework. I can't play that game. Chase people's homework. Can't do it. Don't have the time. You don't turn it in, freebie. I'm going to burn your freebie up, and then you start getting zeros. So playing hardball now on that homework. It's too much of a headache. It's just not right. So get your work in on time. OTA. O-T-A. OTA. On-time assignments. Get them in, Mr. Gilbert. I am back. Okay, and here is test number 7. You took it Friday. If you haven't taken it yet, make arrangements to take it with Mr. Gilbert. Okay, I'm okay. You hanging around. Psalm 19:1, the heavens declare the glory of God, the sky above proclaims his handiwork. Okay, number 2, what does this verse say about space and space objects? What does it say? That just the space creation, all the things that have been created in space, bring God glory. They indicate he created it. So they make him look good. When I say they bring him glory, I like to translate that to make him look good, show him off, that kind of idea. And they should. He made it. Nothing instantly commanded. Thought about it, said it, and got it out of nothing. Wow, what a God. 3 and 4 now. What is it like in space? 2 things. Microgravity is the feeling of weightlessness. We just did that. And vacuum, it's empty of matter, this person said, and that's exactly right. Okay, 5 and 6, name 4 components of the solar system. Well, the sun, for starters, right? Everything goes around it. Heliocentric. The planets, the moons, or satellites. Then you've got asteroids, meteorites, comets, all of those. Okay, for questions 7 through 15, the my vary. My Mercury, very Venus, educated Earth, Mother Mars, just Jupiter, served Saturn, Uranus, 9 Neptune, and, oops, I got the numbering wrong, it doesn't matter, but you got them all. Then that takes care of 15, and then pizza's Pluto. Okay. So, will we have to write my vary this Friday? Yep. Why? I want you to remember it. That's why. Okay, number 16, astronomy is the study of space and space objects. 17, geocentric, Earth-centered. Heliocentric, 18, sun-centered. Planets have elliptical orbits. And let's see what the question was. Describe an elliptical orbit, or an ellipse, oval shape. Number 20, what great scientist discovered the ultimate evidence, data, that the sun was the center of the solar system? Galileo Galilei. Number 21, 99.85% of the solar system's mass, almost all of it, almost 100%. All of this matter is found in the sun. 22, an astronomical unit is a huge measuring stick to measure the solar system. 1 AU is the distance from the sun to Earth. All right, 23, Mr. C argues that planet Pluto still should have full planet status, because the reasons for downgrading it to dwarf planet status are just based on what idea? Evolution. Just based on evolution. Or almost totally based on evolution. All right, inner planets. We just did this. Characteristics 24 and 25. Small, rocky, fast revolvers, slow rotators, and few or no moons, no rings. Okay. Is it outers next? No. Okay. Match the correct inner planet name with a description. Mars is not involved. All right. Same size as the Earth. Venus. 27. Smallest besides Pluto. Mercury. Made mostly of water. Your home planet Earth. 28. 29. Heavily cratered by meteorites. Mercury. Oh, no. That would be correct. It is heavily cratered. My bad. Mercury. Heavily cratered. Duh, Mr. C. Looks like the moon. 30. The hottest. Venus. Venus. A little bit hotter than Mercury. A little bit of a surprise because of the strong greenhouse effect, right? Where carbon dioxide gas traps heat on Venus. Number 31, nitrogen and oxygen in the atmosphere, Earth. About 80% nitrogen, about 20% oxygen. 32, the biggest temperature swing, Mercury. Yes. 33, has many just right characteristics, Earth. 34, looks very much like our moon, Mercury. The reason the hottest planet is so hot, the greenhouse effect. 2 reasons the biggest temperature swing planet goes from plus 850 to minus 250. There's no atmosphere and it's a slow rotator. Yep. 37 and 38, 4 characteristics of the scary planet, aka Venus, where you would die almost instantly 6 ways. Okay? It's got a very thick atmospheric pressure that would crush you like an aluminum can. Nice. Not so nice. Extremely hot, 900 degrees Fahrenheit, would fry you. Okay. It also has, I didn't tell you about this, lightning storms all the time, sulfuric acid rain, and it's got carbon dioxide gas, which is poisonous to you. If this room, your room, was filled up with carbon dioxide and that's all you breathe, you've got 5 minutes unless you get out of there and start breathing oxygen. 5 minutes, and your brain stops working. You kill your brain. Okay? What do we got? Just rights for Earth. See if I can get 20. Okay? Right distance from the sun. It's got the right mass. It's the right size. It's got the right tilt. It's got the right amount of water. It's got the right ratio of ocean to Earth. It's got the right, did I mention nutrients in the soil? I think so. It's got the right temperature. It's got the right, I did distance from the sun. Let's see, what else? It's got the right electromagnetic field to block dangerous cosmic radiation from the sun. It's got the right size moon that has the right mass, the moon that has the right gravity, that gives the right balance. The moon balances the Earth. It stabilizes it. So all of that. It's got the right size star, that would be the sun. It's got the right mass that ends up having the right gases to produce the right amount of fusion, which produces the right amount of heat and the right amount of light. It's the right distance from the sun. So I don't know, there's close to 20 probably. Okay. And then what do we conclude about the dozens of just rights? What do they tell us? That God had to make the earth. It's just right. God made it just right. That's why. Evolutionists go, it accidentally developed all of those. There's actually probably 40 to 50 just rights if you get really picky. Accidentally developed all those 40 to 50 just rights. Yeah, right. Sure. Yeah. And I'm the Easter Bunny. So anyway, silly. Just totally silly idea. Okay, Mars. I want to take you to Mars before I tell you about homework. So off to Mars we go. My very educated mother. Mars, 4th planet from the sun. So it's quite a bit further away from the sun than Earth is. What does that do? That makes it really cold on a day when it's turned away from the sun. Listen to this. The temperature on Mars. So is, so write down your guess. How cold does it get to be on your white sheet? How cold does it get to be on Mars? Write down your guess. It's a winter day. Coldest day of the year on Mars. How cold? So write your guess. Whoever closest, Jolly Rancher. Mr. Gilbert will pay off at the end of the period. Lock it in. 3, 2, 1. Time's up. Minus 200 degrees Fahrenheit. Folks, that's like 80 degrees below zero, colder than Antarctica, where you'd freeze to death. All right, summer day on Mars. On the sunny side, during the summer, all the way up to 70 degrees. Like it was this morning when I went out on my walk. It was nice. 70 degrees Fahrenheit. Nice temperature. Doesn't matter, because what are you breathing in? What is the gas in the atmosphere of Mars? Give me a C. Give me an O. Give me a 2 under that. CO2. What would that be? Carbon. O2. Di is 2. Oxide. Oxides, oxygens. Carbon dioxide. And it's thin at that. A thin carbon dioxide atmosphere. So Mars is cold. It's dry. It's got a thin atmosphere. So why is it red? Orange. I still think it's orange. Everybody goes, oh yeah, the red planet. I'm going to have to give those scientists a colorblindness test. Red is red, orange is orange. I think it's deep orange. It's actually orange. I think it should be called the red planet. I'm lobbying for red planet. Sorry, orange planet. I'm thinking it should be orange. I need to bring in 2 like sheets of construction paper. This is red. This is orange. There's a picture of Mars. What color is it? Okay, what else about Mars? So it's got a carbon dioxide atmosphere. Oh, back to why is it orange? Because the soil has what in it? It's a metal. Its chemical symbol is Fe. What is Fe? Iron. It's got little bits of iron in the soil, and that soil combined, or has combined in the past, with oxygen and water. Mars had water running on its surface at one time. I'm going to prove it in a minute. It had water running on it. Anyway, so iron oxide in the soil, rust. So the soil actually rusts. That's why it's orange. I think it's beautiful. I just think Mars is beautiful. And it's a God thing. Does it bring God glory? Oh, yeah. Did he want it to be that color? Oh, yeah. Yeah. He's showing off these colors when we look at these planets and study them. It's for his glory. It's beauty. It's for our enjoyment. SSRs. For us to enjoy. Yep. Hey, are we doing any more SSRs this quarter? Yeah. How long? Another 3 weeks probably we'll start talking about it. So, another 3 weeks. Do you realize we're only like 3.5 weeks away from Thanksgiving? Isn't that unbelievable? So, yeah. Okay, so far what do we got? Really cold, minus 200, warm on a warm day, 70 degrees Fahrenheit, iron in the soil, carbon dioxide atmosphere, so it's very cold, it's dry, there's no precip, because there's no moisture, so no clouds, okay? And then it has, and you're going to see photos of these, the first thing is it's got a volcano, listen to this, it's got a volcano that's 16 miles high. Mount Everest, what are we talking? Mount Everest, let's see, is about 30,000. So what is that high? 30,000, what is that, 6 miles high? So this volcano by the name of Olympus Mons, you don't have to write it down, but you're looking at it. You're seeing it right now. Olympus Mons is a massive volcano. It's almost 3 times higher than Mount Everest. I mean, woo, it's up there. So, it's Olympus Mons. Are you going to make us write it down and know it? No. Now, I might do a bonus question on it if you want to write it down. Mount Olympus, I think, is the mythical mountain in Greek mythology. Olympus Mons. Mons is mountain, I think. So, volcano, it's volcanic. There's been volcanic activity on Mars. If I ask you, hey, what's the evidence that there was volcanic activity on Mars? What is Exhibit A for your evidence? Olympus Mons. Yeah, massive volcano. By the way, the base of the volcano, if you set it down, it would totally cover up Arizona. Wow. Just, drop, please don't, but if you did drop Olympus Mons into Arizona, it would cover the borders, basically. Wow, it's huge. And then, one other amazing geological object, it has a canyon that makes our Grand Canyon look like a crack in the sidewalk. Is that an exaggeration? Sure. So here it is. This Grand Canyon on Mars was caused by water running on the surface, we think. Just like our Grand Canyon was caused by running on its surface, on Arizona's surface. By the way, the water that carved the Grand Canyon was probably flood water shortly after the flood, where like a huge lake broke. That's a hypothesis. Not from evolutionary geologists, but a number of geologists who are trained PhD geologists say there was a tremendous amount of water stored up above the Grand Canyon, and it was dammed up, and if that broke free and ran down through the loose sediment where the canyon is, it would have just ripped it up and formed it. You look down in the bottom of the Grand Canyon in Arizona now and go, nope, I don't think the Colorado formed the Grand Canyon. You're right. There's no way. I mean, it's nothing compared to the amount of water that would have had to form it. So, okay, listen to the Grand Canyon on Mars. It's called Valle Marineris. Are you going to have us know it? No. Do we need to write it down? No. Valle, I think it's V-A-L-L-E. That might be French for valley. Marineris. I don't know what that means. And anyway, get this. It's 4 times deeper than our Grand Canyon. 4 miles deep. And get this. The Grand Canyon is like 500 miles long. Arizona's Grand Canyon. Valle Marineris is 5 times longer. It is basically, it's as long as the United States is wide from east to west coast. It's a big canyon, folks. It's huge. So one more time. 4 miles deep, 2,500 miles wide. 4 miles deep, 2,500 miles wide. Now, you know what I would have hoped you did? I would have hoped that you wrote all that data down. Do I have it? I do not. That you would have written all that data down on your lesson summary for the planets. Is it, I don't know, 13, maybe 12? Whichever one has the planet data on it. I hope you wrote down all that data about Mars there. Mr. C, I just put it in my planet data in my journal. That's fine. It's equally good, no worries. Oh, one other thing. Mars has huge dust storms. The soil is really loose on Mars. And you might get an idea from this picture right here that you're seeing. We are going to send, in fact, it's on its way. It's halfway to Mars. We have a spacecraft on the way to Mars that's going to drop down, just like that video showed you the other day, how you land on Mars. This is what we're doing. This is the Perseverance spacecraft. Does it have a robot on it? It does. Yeah, and you're seeing the robot right now. The robot is Perseverance. And like hang in there, that's what perseverance means. Persevere, you hang in there. So I think we hope Perseverance will hang in there for years and years and years and gather a lot of data. It's got wonderful instrumentation on it. Does that mean it's like a space probe? Yeah, sure. Space probe. Yeah. And rover combined. So it's got instruments on board. It's a rover. It's going to rove. It's got motors and wheels, and it'll slowly rove across the planet of Mars. Now, all that loose soil that you're seeing in this Perseverance photo right now, all of that loose soil sometimes is blown by several 100-mile-an-hour winds, hurricane winds on Mars. So that would knock you down. They blow so hard. It would just flatten you, knock you down and blow you along the ground. You couldn't stand up. So it causes huge dust storms. And we can see them even in our telescopes from Earth. You can see that Mars looks cloudy at times. I don't know, maybe I'll be able to show you a photo of that. So, okay, your homework, here it is. And you're going to have a bit of time to work on this. So, this is 101D. So there won't be any time for any science activities today. Here it is. And it's on the inner planets. I don't think you've done 101D. And I'm going to write the page numbers on the top and show you, and you're putting those in your lesson planner. So here are the page numbers. Coming up, be patient. Are you being patient? Your answers are from page, see them? 95 to 101. Do we need page numbers? You bet. So page numbers down. And I'm going to turn you over to Mr. Gilbert. And he's going to clarify anything. He's going to pass out 101D. And you're going to get rolling on it. Okay? So, happy Tuesday to you. I will see you on Downhill Day. And I'm going to turn it over to Mr. Gilbert.